Howdy everybody, Steve here, KM9G. Today we're going to play with OpenGD77. And I'm going to do this a little bit differently. Instead of going through and having a polished step-by-step tutorial, I'm going to show you all of the pains and struggles that it takes to make it through to the other end of this process. It isn't difficult, but it's difficult. Let's get started. Don't worry, as always, I've got your back and there will be instructions in the description down below. If you just want to skip all of the pain and go straight for the glory, that's on you, my friend. I am going to be using my trusty Raspberry Pi 4, and so I need to figure out where I put it. What I've done so far is Raspberry Pi Imager, which you guys have all seen before, and got it on the network over Wi-Fi, but I don't know where on the network it is. Let's find it. On a macOS style computer or on a Linux computer, you can use a command called nmap, and on Windows, you can use a program called Angry IP Scanner. Both of them, just look on your network and see what host responds. So let's do sudo nmap, and that is my IP range, and it's a class C address space, so /24. What's my password? No peeking. All right, I have two devices that identify themselves as Raspberry Pi devices, and I really don't like the output of nmap, but it isn't all that bad. It's just what you have to deal with. So that is the block that we're looking for. So 21 is a Raspberry Pi, and 22 is a Raspberry Pi. So let's see if I can get onto one of those. 1.22, well, I guess we'll start from the bottom up. I have not logged into this machine before. I have not seen this key before, so what it's doing is it is saying that it would like me to accept the key or not. I know this is a new host. I know I haven't seen the key, so I'm going to go ahead and accept the key by typing in yes, and it wants my password. And that is the password that I gave it to run, and it doesn't work. So we're going to try one other thing, which is the other machine. Okay, so it has already seen that key as host 21, and now it's on host 22 before. So this is probably not the box I'm looking for, but we'll try it anyway. This one is telling me that I have a key in my host file that doesn't work. It's got a key for this IP address that isn't the key that this server is giving me. I'm going to go ahead and remove that because I experiment all the time. This is not shocking to me. So SSH keygen -R 192.168.1.21 to get rid of the host in question. And now it is gone, and we're going to try to connect to that machine again. Now that it doesn't have a stored key that doesn't match, it's telling me it's got a new key that I've never seen before. You kind of have, but you kind of haven't. I get it. Yes, I'm going to accept it for all the reasons I did before, and it won't let me with my key. So now I know my key is loaded, I think. SDR-PP, SDR++. So this is from a Nuggets live stream that we did before. I just didn't change the host name. That's fine. It will get the job done, and we are in. Verify that it's the right machine because it's been up for about 12 minutes. That seems like it's about the amount of time it's taken me to do this much recording so far. This is a version of Bullseye. I don't recommend Bookworm yet because the rest of the world hasn't caught up to Bookworm. We're going to use Bullseye, which is one generation below, which means I need to do updates. So the first thing I need to do is sudo apt update to update all the repositories on the machine with the repositories from the internet. And it says 16 upgrades available. And we're going to go ahead and upgrade them. All right, I am looking back through the updates that are available, and I don't see any kernel updates, so I don't see any reason to reboot this to activate any of the kernel updates that didn't happen. This is the OpenGD77 user guide, and inside of the user guide you will find some stuff on installation. We're using the Retevis RT-90 that my friend Don N5SKT sent in, and somewhere on this table of contents you'll see installation. And there's a whole lot of stuff to read here, and it actually kind of matters, and then it kind of changes from the instructions a bit, which is why I wanted to show you guys this process. Get the radio into firmware update mode by pushing a bunch of weird buttons. We're using the RT-90, so I need to hold the P1 and the orange button while applying 12-volt power to the radio, so I'm going to need about 4 hands to do that. Upgrading the GD77 firmware to a newer version does not require the power to be removed and reconnected. Just turn on the radio using the green power button whilst holding P1 and orange will enter a firmware update mode. Excellent. So once we get it done the first time, I don't need 4 hands to do it. But we're not ready for that because we haven't downloaded the software yet. So we don't start at installation. Back up to the table of contents. We started download links before installation. Donor file for those radios, donor file for these radios. So I need to download I need to download this donor file from Passion Radio. So I click on that, and it wants to do a bunch of verifications, and it wants to download. And I will download this into this folder. All right, now that I've downloaded it, I need to get it over to the Raspberry Pi machine. So we need to go back to iTerm, and we need to exit out of that and get into the OpenGD77 folder. And the donor file is, I believe it's that zip file, the 210525 file. So I'm going to do scp 210525 to steve at 192.168.1.22. Was 22 the IP address of that machine? No, 21. Colon dot. I'm going to put it into the Steve users home directory. And then we go back onto the 21 machine. And hey, look, there it is. Make a directory for the work that we're doing. I'm going to move the file from the parent directory to the current directory. And I'm going to make a directory called OEM firmware. There's probably about 1,000 different ways to do this. I just want all of these files in a nice clean folder so I don't muddy up the folder above this one. And then if we go back to Firefox, it says extract the donor file and save it to your computer. This is the same for all file names above, so I need that file name, which is 2645.bin, s2645.bin, right? v2645.bin. Okay, so it is that file right there. Let's see if it made it. It did, so I'm going to move that file to the parent directory so I have it where I want it to be. MD-9600 CSV 257 1v5. Oh, I don't like that. All right, so in order to use the parentheses in file names on Linux, you have to escape them by putting a backslash in front of them. So I did backslash open parentheses, and then I hit the tab key, and it's the first one that came up, v2645.bin, and I'm going to copy it to the parent directory with dot dot, because dot dot is the parent directory. And hey, look, there it is. And now to clean up my mess, I'm going to get rid of the OEM firmware folder. So now I have that file that's necessary. And again, there's a million different ways to do that. I know. I just do it out of muscle memory and habit more than anything else. Let's see what's next. We got the donor file. Now we need the firmware binaries. And I need to go into this folder here and get them. And there was something that I read. This is where it gets a little weird. The RT-90 has been produced with multiple different PLL and IF chips during its production run. You need to install the version which matches your hardware version. The version is written on the PCB inside of the top of the radio, except sometimes TYT changed the hardware without changing the version on the PCB. Fantastic. So you could have a version number written on the circuit board that doesn't actually match the hardware that is on the circuit board that the version number is written on. Radios with hardware version 4A use version 5 firmware. For very old radios with hardware version 2 written on the PCB, you may need to be loaded with the version 1 firmware. No harm will be done if you load the wrong firmware, it just won't work. So basically, if your radio does not transmit, try using a different version. So my radio has this version of firmware on it, which means I probably should start out with version 1 of the firmware. So I'm going to start out with version 1 and maybe try version 2, but version 1 looks like it's going to be a safe bet. So let's get back to the firmware download page. These are all written on the same date, so this is hardware version, not software version. 12/12/2023, which is fairly recent as of the recording of this video. I like that. And let's see, I'm going to download this version 1. So I'm going to right click on it. I'm going to copy the link. And I'm going to go back over here and I'm going to do wget, or I could use curl. I'm going to paste in that URL, and now we're downloading. And we're done. Let's take a look at what's in that file. So I guess GLA is language files, and then we have the binary file. So for grins, I'm going to move the MD binary file to the parent directory. And is there an English? Because I speak English. There's no English, so it's English by default. Okay, so now I have my binary files. Now we can get to the installation part. And this is where it gets interesting. This is where it's going to diverge from the Windows installation instructions that you've seen everywhere before, because I don't Windows. Let's see if we can do this. It did take me a while to find the Linux command in order to do this. Now I got to see if I can find it again. Okay, so in order to do this on Linux, you need to do a different procedure than what is on the website, which is one of the reasons why I'm sharing this video with you today. You're going to need the CPS software, but you're going to need the Linux version of the CPS software, and it's extremely buried. It's very hard to find any mention of this whatsoever, and I don't even know if it's going to work on Raspberry Pi, but that's what we're here to do. So if you click on the regular download for the regular CPS, it's going to take you into a folder that has this Linux loader for STM32 radios in it. And I'm going to go inside that folder, and we have a firmware loader file and we have a Python script. So I'm going to copy both of these files over to my Linux machine. And then next up, I'm going to need the latest source code for fully released firmware. And I see nothing in here for the radio in question. So we're going to continue forward and act like we know what we're doing, even though we know we don't know what we're doing. Okay, I see nothing on there, so we're just going to blaze some trails. We downloaded 2 files, and they are firmware loader and the Python. So install my favorite text editor. All right, this is trying to run bash, and it wants to know what operating system I'm on, and then it wants to do some work, so echo some crazy stuff. Okay. Sure. And one of the cool things about Linux is I can copy these commands out. Like, what does this do? So let's copy that and let's paste that. And it looks like it does some control codes and a close parentheses, which is kind of what I already expected it would do. Let's do the entire command. Well, I guess before that, that close parentheses was in a weird spot. Yeah, so there's your control character like I thought. So now let's paste in that command that I copied out, and that's going to set an environment variable called MD-9600. So I want to see what's in that. MD-9600. Nothing. Awesome. And then if we are on Linux, which we are, it's going to run OpenGD77 STM32 firmware loader.py with some commands. So it looks like the firmware loader is a wrapper for the Python script. And the Python script wants to run Python 3, and this is a copy of the pydfu.py script that's been modified. And there's a whole bunch of stuff in there that we need. Excellent. So I'm going to play it safe. I do not have the radio connected. I am not in firmware mode. And this is a Raspberry Pi computer that I can reload the operating system on, and no harm, no foul if I mess this up. I'm going to do bash firmware loader and see what it does. It just gave me a whole bunch of complaints, which is kind of what I saw from running through some of those commands myself. I didn't know that that would work. So let's run the Python script. And I can't run it because it's not executable. So you can do this a couple of different ways. I can look at the first line inside of the Python script, and it'll tell me that it is looking for Python 3 to run it. So I can run Python 3 and give it the file name like that, or I can change the file mode to allow it to be executed. I'll do 755. 777 is too broad. So 755 is I, as the user that owns the file, can read and execute and write the file. And then 5 is if you're in the group that I'm in, you can read and execute the file without writing to it. And then the third 5, which is also the second 5, the third number, which is also the second 5, is also read and execute for everybody. Kind of the same permissions as 777, except you can't write if you're not me. And you can also do, change mod u plus x, so user is now allowed to execute this file. Then I can do /OpenGD77. I do not expect this to run. I expect it to complain about missing libraries. And it's actually complaining that Python 3 isn't there. Sudo apt install Python 3. Okay. So it says /r. That might be a conversion problem from Windows to Linux. So we can run a command called dos2 Unix, which is going to get rid of all of the wrong carriage returns for DOS and make them the right carriage returns, end-of-line characters for Unix. All right, so now let's run it again and see if it complains again. All right, perfect. So we removed the weird line termination characters, and it's saying no module named USB. So I need to install the USB module. So there's a couple of different ways to do that on Linux, especially on Debian-based systems. So I'm going to try and use the apt repositories and stay within the apt ecosystem. And if that doesn't work, we'll break out of that and we'll do it a different way. Apt search Python 3 pipe to grep USB, and I see Python 3 USB and Python 3 USB 1. So I'm going to try this one here. And now when I run the command, I should either get an error that says that it's still missing USB, which means I installed the wrong one, or I will get another error that says I'm missing a different module, or it might run. Failed to connect to the device. Okay, so we have gotten some progress. It now wants me to actually connect to the radio. I knew this was going to happen. Oh, so this is where it's going to get fun. I got to figure out how to use more hands than I have available to get this thing into programming mode. Hold P1 and orange button while applying 12 volts. Hopefully you can do that with the power switch. I doubt it. But P1 and orange button. Let's go try it. We're going to try P1 orange and power. Okay, that doesn't work, but regular power does. Crud. Orange. Oh. My fingers don't work that way. Orange. P1 and power. Nothing. Urgh. So, I don't know. Orange. P1 and... Can I do this one-handed? I need like an on-off switch. There we go. All right, it's flashing. I hope that means something. Okay, now I have got this thing plugged in over USB, and I think it's in programming mode. I'm going to run LSUSB, and I see STM microelectronics device in DFU mode. Oh, awesome. Now, let's run the Python script again. Failed to connect to the device. Yay. Okay, so if we look at it's trying to run it with some commands. Why did you do that again? And again, I had to stop OBS and restart it because I didn't want to record the screen capture. I love software. It's always so delightfully reliable and working perfectly the first time, every time. So the last time we left it, it could not connect to the radio because the radio wasn't plugged in, which was progress. And now I've got the radio into firmware update mode, I believe. I have no idea. It's just flashing over there. And I've got it plugged into a USB cable into the Raspberry Pi. It's for an LS USB. Oh, there it is. STM Microelectronics STM device in DFU mode. So it is connected, it is found, it is ready to go. So now we run the Python command again, and it still says failed to connect to device. Okay. And it wants to do a bunch of extra switches, -M, MD-9600. So it's going to pick one of those strings there. I'm just going to assume that means MD-9600. Before we go any further with this, though, Firefox is sharing its screen. We're going to go over to Firefox. We're going to do a search for this OpenGD77 firmware in their GitHub repository. Hey, look, it didn't find any issues. Let's go back and let's go to the LibreDMR GitHub page. And hey, it didn't find it there either. So I'm not blazing trails because I want to. I'm blazing trails because it's just not documented. So we're back into the documentation. I'm going to do another search in a new tab for the firmware loader file and MD-9600. All right, we've got some information from the forums. And this is Windows stuff. And I don't know why it does this. I only searched for 2 words. And out of the 2 words I searched for, it just ignored one of them completely. So let's do it again. Okay, so Google's telling me that there's nothing there to be found either. So we're going to continue blazing trails. I just wanted to make sure that I waved off anything in the comments that said, you can't do it that way. Why don't you just read the documentation? Because there isn't any. Okay, so now I'm trying to recreate the command line. And it says -M and the radio type. And then -F is the firmware. And then the firmware is the .bin file. So let's do -F. And what is the name of the firmware? It is this one here. And I think that's it. Let's try it. Failed to connect to the device. Why are we unable to connect to the device? Let's do -H. Okay, there we go. Official firmware file used as a codec source. Okay, so we do need to include the source. And we've got vid and PID. So let's look at LS USB and see if we can grab that vid and PID. We cannot. So there's got to be a DFU. There's a DFU utils program. So I'm searching now the apt repository to find the DFU stuff. Because there's a DFU utility that's going to give me those vids and PIDs. df-util. And I know this because I've done this once or twice before, but if not, I would have Googled like how to find the vid and PID for a DFU STM32. DFU is device firmware updater. STM32 is the name of the chip. And it gave me, when I did the -H, it gave me some information that it wants to know USB vendor ID and USB product ID. So that's what I'm going down the path of right now. DFU-util. And list currently attached DFU capable devices. So let's do -L. I just ran DFU-util by itself and it gave me help. Do -L and it can't open the device. And there's the defaults. And I think that was... Yep, that's what it said it was going to use anyway. It was 483 and DF11. So why can't we see it? I just checked. The radio is still flashing. I just unplugged and replugged the whole device in and got it back into DFU util mode because the last time I did it, it wasn't plugged in over USB until after I did it. Order of operations may matter. And it does matter. Awesome. All right, so now let's get back. We learned something new when we ran the -H on the loader. We need the source file. Let's get back up to that command line and let's put in that -S. And that's going to be that weird file name there, -S space, and then we paste that in. And I'm going to go ahead and escape those parentheses because I want it to be the actual name of the file, and not that. Let's try it again. Fingers crossed. 19th time's the charm. Oh, it's doing something. It's erasing stuff. The screen's just black. No need to show you a picture of a black screen. I mean, I can. Here you go. And I hear static. Let's get over there and take a look. Because the first thing I'm going to do is turn that volume down. And it says, settings updated. Press enter. Select language, English. Okay, and we see FM, APRS, 1 watt, 13.3 volts from my battery. Receive A is 144 megahertz. Transmit A is 144 megahertz. Awesome. Okay, so that is a day in the life of a ham radio operator when you are playing around with loading firmware and stuff from weird operating systems that it wasn't designed to be loaded from onto weird radios that it also wasn't designed to be loaded onto. Just gotta kind of play along with it and look for some clues and kind of just pay attention. We just Sherlock Holmes our way all the way through that mess right there, and you saw it in real time how it was done. Well, I did cut out a lot of the fluff to save you some time. It took about a half an hour worth of recording. I still haven't done the video editing while I'm talking to you right now. It took probably a good 4 or 5 hours of pre-gaming trying to figure out how to actually do it. Could it be done? Searching the internet, looking for Raspberry Pi type stuff and all kinds of other things. This is what we do on this channel. Be sure you are subscribed by clicking that button down below, the one that says subscribe, and you'll be able to follow along in all the adventures of when we do weird stuff with weird radios that they weren't supposed to do. There will be more videos on what OpenGD77 actually is now that I have an OpenGD77 radio. In the meantime, there's a video right over here I think you will enjoy next. Thanks for being awesome. I'll see you over there.